Hi. Well, imagine it's a Saturday, and every Saturday your dad makes pasta for you in lunch. So the probability of you eating pasta on a Saturday is close to 100%. Okay. But say a new information comes up, your dad has to urgently go to office. Then does the probability of you eating pasta on a Saturday changes? Probably yes. This is exactly what Bayes theorem tells you. When you know something for a fact, and basis on the fact you know the probability of an event happening. Okay, however, whenever a new information comes up, when a new information comes up, the probability of the event changes. And this is exactly what Bayes theorem tells you, that when you believe in something, the probability of something happening is something that exists in your mind. However, when you are fed some additional information, does your belief change? Well, let's try to understand it with the help of an example. Say it's the season of monsoon, kids are going to fall sick. Okay, so say there are about 100 kids in a school, and let's say 20% of the kids are going to fall sick and 80% of the kids are going to be healthy. Okay, to determine whether the kid is sick or not, there's a test that can be done. Say it's a tongue test, and when the test turns black, so ideally if the kid is sick, okay, so if the kid is sick, the test should turn black, give black, or ideally I should say should give black. Okay, now, and if the kid is healthy, the test should not turn black. Okay, should not turn black. So this is our scenario. Now let's try to see what happens. Suppose, yeah, so suppose what happens is there is a limitation to this test. So when you see, the kids can be grouped into two parts. They're either sick or they're healthy. Okay, 20% of the kids are sick, 80% of the kids are going to be healthy. And then there's the test. The test says this. Okay, when you test it on a sick student, 90% of the time it turns black. However, when you test it on a healthy student, 30% of the time it again turns black. Okay, so what I'm trying to here tell you, think here, see this. Okay, think of this test. Either a kid can be sick or the kid can be healthy. Okay, however, when a kid is sick, 90% of the time the test is giving correct results, it is turning black. However, 10% of the time the test fails, it does not give black. Okay, similarly, when you do the test on a healthy student, 30% of the times it turns black. However, 70% of the time it does not turn black. Now I have a question for you. I have a question that suppose from this group of 100 kids, suppose from the group of these 100 kids, a random kid is selected. A random kid is selected for the test. And the test turns black. What is the probability? That the kid is actually sick? Because you do know that the test, of course, 90% of the time it does turn black when the kid is sick, but also a kid could be healthy. 30% of the time the test would still turn black even though the kid is healthy. So now a random kid is selected and a test is done on that student, and we want to know, and it does turn black. Now you tell me, is the kid sick or is the kid healthy? What is the probability of the student being sick is what we want to know. Let's try to find out how do we do it. Pause this video and think for a while. Alright, let's try to break this problem. Well, you have 100 kids, right? You have 20 sick and 80 healthy kids, right? 20 are sick and 80 are healthy. Okay, when you do this test on sick students, 90% of the time it is going to turn black, 10% of the time it's not. 80 on healthy students, 30% of the time it's going to turn black, but 70% of the time it is not. So for how many students is the test going to turn black who are also sick? 18 students, right? 18 kids. And 90% into 20 gives you 18 kids. So for 18 kids, the kids are sick. Out of those 26 students, for 18 students, the test is going to turn black. But for the remaining 2 students, 20 into 10%, for remaining 2 kids who are sick, yet the test will not turn black. Alright? Now, let's think about the other kid. So here, both the students are healthy, okay? All the 80 students are healthy. But 30% of the time, which is basically for 24 kids, the test is going to turn black, even though they're healthy. And for 7, 8, that's 56. For 56 kids, the test is not going to turn black, okay? Now, what was our fundamental question? The question is, a test, a kid is randomly taken and done a test and the test does turn black. What is the probability that a kid is sick? They want to know what is the probability of the kid being sick when the test is black, isn't it? Isn't what the essentially question asking you? What is the probability that the kid is sick when the test does turn black? Let's try to calculate. How many sick students are there? How many sick students are there? Tell me. 20. You know it, right? Should I write 20? Well, no. Why? Because you also know that the test did turn black. For how many 6 students did the test turn black? For 18 kids. So, in fact of 20, I should be writing 18 as my numerator, divided by, for how many students did the test turn black? Here you know that for 18 students, the test turned black, and for 24 healthy students also, the test turned black. So, this gives you 18 plus 24. It gives me 18 by 42, which gives you a probability of, say, around roughly 43%. Now, what do you take away from this entire work that we have done? Remember, initially I did tell you that the test was 90% effective. If it is tested on a sick student, 90% of the time it is going to give you it's going to give you the right results, right? However, when randomly a student is taken, you see, even though the kid was sick and even though the kid is sick, and the test was also black, yet the probability of that happening, the accuracy of the results is still 43%. Why is that? It's simply because we also had an additional information that the test does give black results even though the kid is not sick, which was 30% of the times. Well, if you're still a bit doubtful, let's try to think about another question. What if the question was that a student was selected randomly for a test and this time the test did not turn black. However, the kid has the disease. The kid is sick. So the test did not turn black. However, the kid is sick. So what is the probability of a kid being sick when the test did not turn black? Well, let's try to find out. Let's go by our previous framework that we had created to make things simpler. We knew that there are 100 kids, right? We know that 20 are likely to be sick and 80 are likely to be healthy, okay? And when we knew that, we also knew that out of these, 90% of the time when the test is done on a sick student, it is going to turn black, and 10% of the time it is not going to turn black, okay? Similarly, for the healthy kids, we know that 30% of the time when the test is done on a healthy kid, it is going to turn black, and 70% of the time it is not going to turn black. What is the question again? The question is, what is the probability that a kid is sick even when test is not black? Let's try to solve this. Well, think about it like this. For how many students is the test not black? Well, you can see, I just forgot, let's do the calculations here. 90% into 20 gives 18 kids. Here it gives 2 kids, right? 20 into 10% gives you 2 kids. Again, 80 into 30% gives you 24 kids. And 80 into 70% gives you 56 kids. Now, tell me for how many kids did the test is not black? The test was not black. 2 kids here and 56 kids here. Total 58 kids, the test did not turn black. However, we want to know what is the probability of the kid is sick. Well, what is the probability? Where are the kids who are sick yet the test did not turn black? Well, you know that 20 kids are sick for sure. However, for them, out of those 20, only for 2 kids, the test did not turn black. That means for only 2 kids, the test does not turn black, even though the kid is sick. What does that give you? 2 by 58 gives you roughly a probability of about 3.4%. Alright, so what is the key takeaway from this lesson? What does Bayes theorem tell you? Why is it even important? Well, essentially what it tells you is that you will know some facts and there is an existing probability of something happening based on some facts that you already know. Then some new evidence comes up, some new information comes up, right? That changes the likelihood of this existing probability and gives you a new probability. So if we go back to our first question, the first question was that what is the probability of the kid being sick when the test turns black? The answer turned out to be around 43%. Why? Even though the test detected 90% of the time the disease correctly when used on a sick person, but since the test is being done on a student at random and the test has a limitation, the new evidence was this, that 30% of the time it does turn black even when the kid is healthy, which completely altered this new probability, and from 90% accuracy we reached at around 43% accuracy. So I hope this helps you understand that Bayes theorem tells you that you will always have some conceptions in your mind, but when you are fed some new information, the existing conceptions are going to change and there are going to be some new beliefs, and this theorem proves that.